Hello there. Today we'll be doing number 28 of Neetcode. Let's see where we're at. 28. We're doing counting bits. So in this problem, we are going to count the bits. It's very similar to our previous problem, number of 1 bits. We're just counting the number of 1 bits for all the items from 0 all the way up until n. And so we can do something very similar to earlier. So we can create a result equals an empty array. Then for I in range of 0 all the way up to n plus 1 because we need to get to n. And let's start with the num zeros for that item. So while I, as usual, nums of 1 is plus equals I mod 2. Remember, when we do the mod of 2, every odd item is going to give us a 1, and we're going to bit shift that item by bit shifting for a whole number. We just divide it by 2 because that way we remove one item from the beginning, just shifting the whole column down by 1. That's how we shift, and we just the result is going to append the number of 1s that we found in that particular item I after the item. This is a constant time, so this is O of times the for each loop, which is O of n, and then we can return the result. This should work for us, no problem. It's going to be slightly slower than the solution that is presented by Neetcode with his DP solution, but we can also go over that solution as well. So the DP solution involves, you can watch a very clear explanation that he has with a lot of code, but there are repeating answers that is occurring. So as you can see, there are 4 zeros here. That's for the first one, and 1 0 0 1 0 and 0 0 0 1 1, and eventually you get 0 1 0 0. At this point, you see that there is a repeating that happens here and that happens here. If we keep moving down, we will have an issue where we have that happen, where everything shifts. So every bit shift, the same operations repeat itself over and over again. So we can add that to hold that one place by adding 1, and then just adding the offset of these items. So what I mean by that is I'm just going to just write it out here. So this is going to be 1 plus the dp of just the I, which is the item here, minus the offset, which is this is going to be an offset of 4, so that would be 0 right here. I would be 4 minus 4, offset of 4, and would be 0. The offset here it would be the 2, so I minus offset, which is at 2, and so on and so forth. And this would be I plus the dp minus the offset as well. The offset here is going to be 8. And we're just going to add everything in between, and that will give us our answer. If you want a more detailed explanation, you could check out Neetcode's video, and also check out his website as well. So I'm just going to go for it now. So 0. So we're going to set ourselves up with our dp n plus 1, so we can store this stuff, and we set an offset equals 1 for I in range. I don't know if your interviewer, I'm pretty sure interviewers wants the DP solution if you ever encounter this problem. So he's going to show you the patterns and ask you to figure it out probably. So here we are. The reason why we have to multiply by 2, if we get to that offset, we're going to have to change the offset so that we are adding the right item, for our dp. So our dp of I at this point is going to be equal to, as we saw earlier, dp of I minus the offset. And once that is done, we can return the dp. This is much faster because we are, well, it's not that much faster. I mean, well, it's O of n, and yeah, it's the same. Maybe it's slightly faster because we're O of 32, and that's O of n. But I mean, pretty much it's almost the same speed. what, with half the speed. Okay, anyways, that's all. If you have any questions, comment below. If you enjoyed the video, like and subscribe. And for more videos, check the link that's in the description below. Thank you very much, and have a good one.